Aerodynamics in Aircraft Commercial Written Questions, Part 2. An airplane that is unstable around the lateral axis will dive and climb progressively steeper. Why is stalling airspeed higher when the CG is moved forward? Increased wing loading. In steady-state level flight, the lift will oppose the downward force of weight. Refer to Figure 1. When in steady-state flight with the airspeed represented by point A, the airplane total drag will be at minimum. When an aircraft leaves ground effect, induced drag will increase. Longitudinal stability is measured about which axis? Longitudinal about the lateral axis. Lateral. Which statement is true regarding the forces in a steady level climb? The sum of the four opposing forces is 0. Following a standard right turn to the left, you retract the landing gear and your airspeed increases 12 knots. In order to maintain standard right turn, you should increase the angle of bank. If an airplane is 60 degrees constant bank turn, you should expect the airplane to stall at the same angle of attack as in level flight and higher airspeed due to an increase in load factor. Refer to Figure 2. We demonstrate steep turns and want to review the stall speed at a 45-degree bank, gear and flaps up, power on. The stall speed would be 64 knots. Your planned departure will be from an airport with a higher density altitude than what you have previously experienced. You should know that under this condition, the indicated airspeed at liftoff will remain the same. How will lift and drag be affected when an airplane enters ground effect? Lift will increase and induced drag will decrease. Structural damage or failure is likely to occur at airspeeds above V and E. Which center of gravity position could create undesirable flight characteristics, including decreased static longitudinal stability, decreased dynamic longitudinal stability, control difficulties, violent stall characteristics, and light control pressure? CG aft of the CG envelope. Refer to Figure 3. At which angle of attack will the drag be minimum? So we look at our LD max, it goes down to the 6 degrees for the angle of attack. 6 degrees. While making a standard rate left turn, you raise the landing gear and your speed increases by 12 knots. To stay coordinated, you increase your bank angle. What condition contributes to nose heaviness, possibly making it difficult or impossible to flare on landing? Center of gravity forward of the CG limit. Why is it important that a pilot lower the speed of his or her aircraft to or below design maneuvering speed when in rough air conditions? It will allow the aircraft to stall before load limits are exceeded. Refer to Figure 1. What does point A on the graph 1 represent? Maximum lift over drag. A stall can occur at any pitch, attitude, and airspeed. Refer to Figure 3. The angle of attack that provides the most lift for the least amount of drag is approximately 6-degree angle of attack. Again, LD max, 6-degree angle of attack. While flying straight and level in trim condition, the pilot pulls back on the yoke momentarily. If the airplane remains at the new attitude, when pressure is released, the airplane displays neutral static stability. One of the main functions of flaps during the approach and landing is to allow a steeper than normal approach without increasing airspeed. When in a standard rate turn, if airspeed is increased to keep the same rate of turn, the bank angle must increase. ATC instructs you to slow your airspeed and maintain your last assigned altitude. As airspeed decreases, the angle of attack will need to increase to provide the lift required to maintain altitude due to slower airspeeds. Refer to figure 2. You're in a descent turning base to final with your power on, gear and flaps down, and 30-degree bank. But then you move your power back to idle. What will happen to your stall speed? The stall speed is going to decrease by 12 knots. What change in airplane longitudinal control is required to maintain altitude while airspeed is being increased? The angle of attack is decreased and compensated for the increase in lift. Refer to figure 4. Again, we don't need to look at the figure. 3,000 times 2 G's equals 6,000 pounds. Would indicated airspeed and calibrated airspeed be equal at cruise and higher airspeeds? You're going to an airport that has a higher density altitude than your departure airport. When you get to the airport, you can expect your aircraft performance to decrease. Going to higher density altitude equals performance decrease. Flying a multi-engine airplane, stall should be conducted no lower than 3,000 feet above ground level. What wing platform is preferred in the design of low-speed airplanes? Has a tendency to stall first at the wing root, provides adequate stall warning and aileron effectiveness, which is usually quite stable. Rectangular. Compared to best glide speed, minimum sink speed occurs in an airspeed that is lower. What conditions would result in a spin if a multi-engine airplane was stalled? Asymmetrical power. If a spin is encountered in a multi-engine airplane, most manufacturers recommend retarding both throttles to idle, applying full rudder opposite the direction of rotation, and applying full forward elevator/stabilizer pressure, the aileron's neutral until the spin has stopped. Then adjust your rudder pressure, back elevator pressure, and power to return on the desired flight path. As you slow a multi-engine airplane, in which condition would the airplane reach a stall condition the soonest? Airplane CG has shifted forward during the flight. While manufacturers recommend recovery procedures take precedence, while the manufacturer's recommended recovery procedure takes precedence, generally the first step of the fundamentals of stall recovery for an airplane is to disconnect autopilot or wing leveler if equipped. Kinetic energy is the amount of energy due to airspeed. A split flap indication, one in which the flaps deploy or retract while the other remains in position, is indicated by what aerodynamic situation? A pronounced roll to the wing with the least deflection when flaps are extended/retracted. As an airplane slows, what are the indications of an intending stall? Mushy flight controls as the speed is reduced. When would a pilot most likely enter an accelerated stall inadvertently? In a base to final turn when overshooting. Why does true airspeed differ from indicated airspeed as altitude increases? It's due to lower air density that impacts the pitot tube and static port. What are Vx and Vy? Vx is most altitude gain over a given distance. Vy produces the most altitude gain per unit of time. With a fixed pitch prop, what is the first indication of carb ice? Decrease in engine RPM. When practicing accelerated stalls, the speeds VA and VO should not be exceeded because the positive design limit load factor can be imposed by gusts or full deflection of a control surface, causing structural damage. Stalls may occur as a result of improper airspeed management while distracted by one or more other tasks. For most of the straight-wing airplanes, the wings are designed to stall at the root first. Aircraft energy management is a function of gaining energy through thrust and losing energy through aerodynamic drag. During slow flight, the aircraft becomes less controllable as the center of gravity moves aft. The critical angle of attack remains constant. What part of the pedostatic system uses impact pressure to operate the associated instruments? The pitot tube, frame air. What do manufacturers/POHs suggest as a primary way to avoid an impending stall? Decrease your angle of attack. What type of climb will give you the most altitude gain over a given horizontal distance? Vx. What is the purpose of trailing edge flaps? They increase the lifting force of the wings. What does an airplane stall at a higher airspeed with a forward CG? The critical angle of attack is reached at a higher airspeed due to increased wing loading. What is usually the first step when recovering from a stall? Reduce your angle of attack. What is true regarding an airplane in ground effect in comparison to an airplane conducting a go-around? Reduced induced drag requires less power to maintain airspeed. Turbulence can cause an aircraft to stall at a higher airspeed than in stable conditions. During the final phase of an approach to landing, as the aircraft nears the ground, power should be reduced to offset the increase in lift caused by ground effect. During an engine failure, which airspeed provides the highest lift-to-drag ratio? That's glide airspeed, VG. What are the dominating factors of the atmosphere that have major effects on performance? Pressure and temperature. After starting a reciprocating engine, what does a very high, continuous draw on the ammeter indicate? The starter has failed to disengage. When an airplane is in a spin, it rotates around a vertical axis, and the rising wing is less stalled than the descending wing. It says, please read the explanation. Sure. Unless otherwise specified by the manufacturer, what are the first 3 steps when encountering a spin in an airplane? Reduce power idle, position the ailerons to neutral, apply full rudder against the direction of the spin rotation. 14 CFR Part 1 defines Vx as speed for best angle of climb. Vx, speed for best angle of climb. When wanting to increase your aircraft performance as you use fuel and the aircraft gets lighter, reduce power to maintain optimum airspeed. During an accelerated stall, which primary factor causes the stall speed to increase? Higher load factor due to maneuvering. What factor increases the likelihood of a spin during a stall? Poor yaw control. What airspeed can a pilot expect to see during a spin? Very low, usually within 2 knots of the unaccelerated stalling speed. Spin recoveries are usually executed with a nose-low attitude, high airspeed, and high load factor.